So we're Team Echo. I'm Yojan and I worked on the Android app for the system. So our brief was to design a multi-touch conferencing system that simulates a physical conference in a virtual environment. We use a multi-touch system to take full advantage of this. So when researching, we figured that when you're in a physical conference, the problem is that you're confined to a single location. If you have virtual systems, then the problem is that everybody is talking about the same thing. And that can be really annoying for some users who are not actually interested in the current topic being discussed. So the natural solution to that is to split the conference into many conversations, but that many systems do these days, but we feel this is an incomplete solution since you can be in a conversation that you still might not be interested in with seclusion from all the other conversations going on. In a physical conference, what happens is you overhear people, you judge body language, and you see your friend across the room and you know he might be discussing something of interest. So what we did was try and emulate the overhearing aspect in our Android app. What that does is it takes into account the user's profile, which includes the interests, the job title, and the company he works for, the conversations that have been taking place in the conference recently, the messages that have been taking part in those conversations, and we have a metric algorithm that decides which conversation the user is likely to be interested in. We also have notifications for messages, and we have context searching for conversations based on the content of the messages that have been recently sent. So these are a few screenshots from the Android app that we've developed. Once the user has registered and logged into the app, he's presented with all the conversations in the conference currently. He can then use the really intuitive messaging interface, very similar to a recent $19 billion acquisition. And then he can also see all the users in the current conversation, find out more details about the users, and say if somebody else in the conversation says something of interest, he can then directly email or phone them. We also have the ability to scan the QR codes from the touch client that Peter will discuss to you now.
Okay, so hello everyone, I'm Peter. I've worked on the data analysis module in the project, and I'm going to talk to you about the touchscreen. So basically, our main purpose for the touchscreen was to use it as a tool for enhancing the conference rather than actually communicating within it. So on this screenshot, you can see we display 5 of the most popular conversations at any time, and this gets updated all the time. And you have literally all the stats that you need for those conversations. You have all the messages within them, the avatars of the users, tag clouds, QR codes, and you also note the global panel in the top that displays various kinds of data visualization. We have taken full control of touch gestures, as you can see on the next screenshot. Everything can be arbitrarily rotated, moved, and stacked upon one another. The global panel has 2 advanced data visualization techniques. One of them is the tag relation diagram, which shows the most popular keywords within the conference. And when you highlight one of them, it also highlights the relations that it has to other keywords in the other conversations. A green line basically means that it happened within the same conversation, but in the same message but before, and red means that it happened afterwards. And we also have this really cool overview force-directed graph, which displays all the conference objects, the conversations, and the users, how they link together, and users might use this to more easily pick which conversation they want to join. So to feed this, we have used the keyword distraction algorithm that is basically inputs to these visualizations. The main challenge why we want to do it like that is because real-world communication is not ideal, as is demonstrated by this tweet here. So basically, the first thing we want to do is get rid of the capital letters. So basically, we convert everything into lowercase. We apply a regular expression to get rid of the non-letter characters. We split the string using whitespace as a delimiter. We perform one spell checking pass over the entire list of strings. We get rid of the words which have no meaning, which are not really necessary for our analysis, such as what, off, and so on. We perform a brutal stemming algorithm to get the word reduced to its base form quickly, because we need this in real time. And the stemmer might make some mistakes, so we do another spell checking pass over the entire thing to get the final list of keywords, and we're done. Basically, so that's it. Final thoughts, you can check out our source code on GitHub, and we have really enjoyed working on this project. We hope to keep extending it in the future, and thank you.